My practice is about the speed of sound. The question is, does sound travel faster and warmer or colder? My hypothesis is that sound travels faster and warmer. The materials used to find the speed of sound is 3 different kinds of tuning forks with different frequencies, and a rubber pad for the tuning forks to hit, a thermometer to measure the air temperature, a resonance tube, and a graduated cylinder. So the procedure is to fill the graduated cylinder with water, as I did here, and place a resonance tube inside the water. And you also have to record the air temperature, which right now is 72 degrees Fahrenheit. So when you hit the tuning fork and the sound goes inside the resonance tube, whenever the sound is heard the loudest, that means it has reached its quarter wavelength. But now if I tap the tuning fork on the rubber pad, it will not hear clearly because it has not reached its quarter wavelength yet. But then if I adjust it to its quarter wavelength, it will resonate. So now if I hit it, it will make a loud sound. Do you hear that? That means now it has reached a quarter wavelength. But then if I use another frequency, such as 640 Hertz, it will not resonate because for each frequency, it has its own quarter wavelength. But now let me adjust it to 640 Hertz, which the quarter wavelength is 440 centimeters. See, you heard the loud sound. That means this has also reached its quarter wavelength. So I also experimented this at home by pouring hot water and heating the air with a hair dryer, as I did here, which I put hot air, and I also put ice inside to make the air cold, and I also left it overnight, as I did here, where I'm holding ice. So the results are that for 512 Hertz, which is the frequency, the temperature was 67 degrees Fahrenheit. And the quarter wavelength of 512 Hertz is 16.7 centimeters. So now to find the speed of sound, a quarter is 4. So then you have to do 16.7 centimeters times 4, which is 66.8 centimeters. And if you want to make it easier, you can to convert it to meters. It is 0.66 meters. And now to find the speed of sound, you have to do 512 times 0.66 meters, which is 342 meters per second. The real speed of sound is 343, but my 342 meters per second is close. So the conclusion is that a sound always depends on air temperature, and as the temperature increases, the sound also becomes louder.